Gotcha. Mosquitoes. I hate them. Don't you? That awful buzzing sound at night around your ears that drives you absolutely crazy. Knowing that she wants to stick a needle in your skin and suck out your blood. That's awful, right? In fact, there's only one good thing I can think of when it gets to mosquitoes. When they fly into our bedroom at night, they prefer to bite my wife. But that's fascinating, right? Why does she receive more bites than I do? And the answer is smell, the smell of our body. And since we all smell different and produce chemicals on our skin that either attract or repel mosquitoes, some of us are just more attractive than others. So my wife smells nicer than I do, or I just stink more than she does. Either way, mosquitoes find us in the dark by sniffing us out. They smell us. And during my PhD, I wanted to know exactly what chemicals from our skin mosquitoes use, African malaria mosquitoes use, to track us down at night. And there's a whole range of compounds that they do use. And this was not going to be an easy task. And therefore, we set up various experiments. Why did we set up these experiments? Because half the world's population runs the risk of contracting a killer disease like malaria through a simple mosquito bite. Every 30 seconds, somewhere on this planet, a child dies of malaria. And Paul Levy this morning, he was talking about the metaphor of the 727 crashing in the United States. Well, in Africa, we have the equivalent of 7 jumbo 747 crashing every day. But perhaps if we can attract these mosquitoes to traps, bait it with our smell, we may be able to stop transmission of disease. Now, solving this puzzle was not an easy thing, because we produce hundreds of different chemicals on the skin. But we undertook some remarkable experiments that managed us to resolve this puzzle very quickly indeed. First, we observed that not all mosquito species bite on the same part of the body. Strange. So we set up an experiment whereby we put a naked volunteer in a large cage. And in that cage, we release mosquitoes to see whether they were biting on the body of that person. And we found some remarkable differences. On the left here, you see the bites by the Dutch malaria mosquito on this person. They had a very strong preference for biting on the face. In contrast, the African malaria mosquito had a very strong preference for biting the ankles and feet of this person. And that, of course, we should have known all along, because they're called mosquitoes, you see? That's right. And so we started focusing on the smell of feet, on the smell of human feet, until we came across a remarkable statement in the literature that said that cheese smells after feet rather than the reverse. Think of it. And this triggered us to do a remarkable experiment. We tried with a tiny little piece of Limburger cheese, which smells badly after feet, to attract African malaria mosquitoes. And you know what? It worked. In fact, it worked so well that now we have a synthetic mixture of the aroma of Limburger cheese that we're using in Tanzania, and has been shown there to be 2 to 3 times more attractive to mosquitoes than humans. Limburg, be proud of your cheese, as it is now used in the fight against malaria. That's the cheese, just to show you. My second story is remarkable as well. It's about man's best friend. It's about dogs. And I will show you how we can use dogs in the fight against malaria. One of the best ways of killing mosquitoes is not to wait until they fly around like adults and bite people and transmit disease. It's to kill them when they're still in the water as larvae. Why? Because they're just like the CIA. In that pool of water, these larvae are concentrated. They're all together there. They are immobile. They can't escape from that water. They can't fly. And they're accessible. You can actually walk up to that pool and you can kill them there. Right? So, the problem that we face with this is that throughout the landscape, all these pools of water with larvae, they are scattered all over the place, which makes it very hard for an inspector like this to actually find all these breeding sites and treat them with an insecticide. And last year we thought very hard, how can we resolve this problem? Until we realized that just like us, we have a unique smell, that mosquito larvae also have a very unique smell. And so we set up another crazy experiment, because we collected the smell of these larvae, put it on pieces of cloth, and then did something very remarkable. Here we have a bar with 4 holes, and we put the smell of these larvae in the left hole. Ooh, that was very quick. And then you see the dog. It's called Tweet. It's a border collie. He's examining these holes, and now he's got it already. He's going back to check the control holes again, but he's coming back to the first one, and now he's locking into that smell. Which means that now we can use dogs with these inspectors to much better find the breeding sites of mosquitoes in the field, and therefore have a much bigger impact on malaria. This lady is Ellen van der Zweep. She's one of the best dog trainers in the world, and she believes that we can do a lot more. Since we also know that people that carry malaria parasites smell different compared to people that are uninfected, she's convinced that we can train dogs to find people that carry the parasite. That means that in a population where malaria has gone down all the way, and there's few people remaining with parasites, that the dogs can find these people. We can treat them with anti-malarial drugs and give a final blow to malaria. Man's best friend in the fight against malaria. My third story is perhaps even more remarkable, and I should say has never been shown to the public until today. Yeah. It's a crazy story, but I believe it's perhaps the best and ultimate revenge against mosquitoes ever. In fact, people have told me that now they will enjoy being bitten by mosquitoes. And the question, of course, is, what would make someone enjoy being bitten by mosquitoes? And the answer I have right here in my pocket. If I get it. It's a tablet. Simple tablet. And when I take it with the water, it does miracles. Thank you. Now, let me show you how this works. Here, in this box, I have a cage with several hundred hungry female mosquitoes that I'm just about to release. Just kidding, just kidding. What I'm going to show you is I'm going to stick my arm into it, and I will show you how quickly they will bite. Here we go. Don't worry, I do this all the time in the lab. There we go. Okay. Now, on the video here, I'm going to show you exactly the same thing, except that what I'm showing you on the video happened 1 hour after I took the tablet. Have a look. That doesn't work. Okay, sorry about that. I'm sticking in my arm, I'm giving them a big juicy blood meal, I'm shaking them off, and we follow them through time to see these mosquitoes get very, very sick indeed, here shown in fast motion. And 3 hours later, what we see on the bottom of the cage is dead mosquitoes. Very dead mosquitoes. And I'm going to say, ladies and gentlemen, we have swapped the cards with mosquitoes. They don't kill us, we kill them. Now, Maastricht, be prepared. Now think of what we can do with this. We can actually use this to contain outbreaks of mosquito-borne diseases, of epidemics, right? And better still, imagine what would happen if in a very large area, everyone would take this drug for just 3 weeks. That would give us an opportunity to actually eliminate malaria as a disease. So, cheese, dogs, and a pill to kill mosquitoes. That's the kind of out-of-the-box science that I love doing for the betterment of mankind, but especially for her, so that she can grow up in a world without malaria. Thank you.